A correlation coefficient in your calculator is the R value. And the R value basically tells you when you have a data set and you're making a scatter plot, let's say, of your data set, your correlation coefficient, or your R value, tells you how good of a line it represents. So basically, back in middle school, you guys might have had something that looked like this. No, that's kind of terrible points. Let me redo that. Let's say, try to do a little better job. Let's say points here, 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 here. Alright, so if I looked at something like that, or if I looked at something like this, or if I looked at something, let's say like this is similar to what you guys did in middle school. Well, the first one, basically we have our points in there. It's making kind of a positive trend. It would look something, if we were to do a line of best fit, it would look something around like that. That's a positive correlation. Our second data set, basically our line of best fit would look something like that. That's a negative correlation. And this last one, it really doesn't have a line of best fit. I can make a line that goes negative, I can make a line that goes positive, vertical, horizontal. None of them really fit the data, so this one is a no correlation. And basically that's about what you did in middle school when you were dealing with these. You had to identify positive correlation, negative correlation, or no correlation. Well, now in Math 1, we actually want to find the correlation coefficient, and R value that's going to tell us how good a line fits to the data. So if you need anything from the screen, go ahead and get it. I'm going to clear off the screen. Alright, so again, an R value is your correlation coefficient. It should be my value right there. That did not, sorry. There we go. Our correlation coefficient. Now, like I was saying, your correlation coefficient tells you how good a value fits to your data. So, I'm going to look at our correlation coefficient as a line. Now, your correlation coefficient can go all the way from 1 to -1. So your correlation coefficient, or your R value, is always between 1 and -1. Alright, so a correlation coefficient of 1 means it makes basically a perfect straight line. And we're going to say a positive line. So if I have an R value equal to 1, that would look something like this, where all of our dots are pretty much making a perfect straight line. Okay, so an R value equals 1 means that it's going to have, basically our dots are perfectly aligned to a linear line, whereas if our R value is a -1, it is a perfect negative line. Which just means that our points are going to line up perfectly in the negative direction. Okay, so that right there is an R value equal to -1. So an R value that's equal to 1 or -1 is a perfect straight line with our data. Now, you can also have a correlation of 0. Correlation of 0 would be kind of like what we looked at on that previous page, where they just really have no direction to it. It could be positive, it could be negative, it could be vertical, it could be horizontal, and none of them seem to fit any better than anything else. So that would be an R value equal to 0. Now, an R value can be anywhere between -1 and 1. The closer it is to 1 or -1, the better the line represents, or closer to a line the data represents. So if you need anything from the screen, go ahead and get it. We're going to look at a couple examples. Alright, so we're going to estimate necessarily first. So let's say I had something like this. Okay, so if I look at that one, my line of best fit would probably go somewhere like that. Now, do all my points line up perfectly on the line? No, they don't. So it's not going to be a perfect R equals 1, but my points do kind of follow a positive trend to it. This would probably be something like an R value of 0.95, just kind of as an estimate. Whereas if I had something like this, you know, I can obviously see that my line or my dots go in a negative direction, so it would look something like that. Again, it's not perfect, so it would be something like a negative 0.95. Okay, so this is the kind of things that our R value tells you. So instead of going through and doing all the work that you did in middle school, making scatter plots, looking how well your points line up to make a line, in Math 1, our calculator is going to calculate an R value for us, which basically tells us, you know, does it make pretty much a straight line? Is it positive? Is it negative? Is it a good fit for a line of best fit or not? So if you need anything from this one, go ahead and get it. Alright, so one of our examples that we're going to look at is you're going to have questions where they're going to say, for example, you have an R value of negative 0.25. And we want to figure out, is that a strong positive? Is that a weak positive? Is that a strong negative? Or is that a weak negative? Okay. Now, we'll go through and calculate how to find your R value as well here in a little while, but one of the examples I know you'll have for my test and probably on your exam as well is you'll have some sort of a story problem that will say, you know, this data had a correlation coefficient of R equals, in my case, negative 0.25. We want to determine if that's a strong, weak, positive. Well, automatically, when you look at your R value, in this case, it is a negative number, so automatically I can get rid of these two. And I know it's going to be a negative correlation because it has a negative R value. Now we have to determine whether it's going to be strong or weak. Well, as you guys progress beyond Math 1, your definition of what's considered strong and weak will change. But really for Math 1, the nice thing is it's either very obviously strong or very obviously weak. It's either really close to 1 or negative 1, or it's really close or closer to 0. Generally, pretty much they'll put things in the 90s. Anything in the 90s, whether positive 90s or negative 90s, is a really good correlation. It's a strong correlation. Anything closer to 0, so like 0.1, 0.2, 0.3, 0.4, those are all weak correlations. They're not going to give you, and just like I'm not going to give you one that's like a 0.84 and say, you know, determine your correlation. That's kind of, you know, not very nice to do. But in this case, 0.25 is much closer to 0 than it is to negative 1 in this case. So this one would be considered a weak negative. Whereas if I had something, let's say, for example, I had an R value of 0.98. Okay, that is definitely, that's positive, so that's a positive correlation. And then 0.98 is really darn close to 1, so that's a strong positive correlation. So when you get an example like this, where it's just giving you the R value and you're determining what would be strong, weak, again, anything 0.85 or better is considered pretty strong, especially in the 90s, and then positive or negative, just if it's positive or negative.